anchor for this mega event, which is called as India Rubber Expo Mumbai 2024, brought to you by AIRIA. Well, I'm sure all of us are having a super wonderful time out here, and indeed, that is how it should be. Well, as we all know, ladies and gentlemen, this is the final day of India Rubber Expo Mumbai 2024, and I'm sure all of you have benefited in abundance in last 2 days, making new work connections, making friends, and above all, learning new things at India Rubber Conference from our esteemed speakers. IRE this year had a sole purpose of creating a bright future for the industry. That's why Shri Vishnuji Bhimrajkar decided that it has to be really grand. And look what 2 days we had. We had the biggest minds of the industry here and also had biggest names of Bollywood to entertain all of us. As we know, IRE is a grand success, but still, we have 2 final sessions left and few more esteemed speakers to enrich us and enlighten us. Being an anchor and host of this mega event, I would indeed like to express my heartfelt gratitude to all our exhibitors, sponsors, and the organizing team for putting forth their efforts and dedication in making this event the best of all. So can we have a huge round of applause for all of us who are associated with IRE? Everyone, let's have a huge round of applause. And now, my dear friends, it's time to begin our first session today, and may I have the pleasure of inviting on stage our speakers for this session, Mr. John Kunavis, Mr. Chetan Bhangle, and Mr. Sandesh Nandre. Ladies and gentlemen, let's put our hands together and welcome the 3 speakers on the stage. Yes, ladies and gentlemen, a heartfelt welcome to Mr. John Kunavis, Mr. Chetan Bhangle, and Mr. Sandesh Nandre. All right, now to take forward the proceedings, I request all 3 gentlemen, welcome, heartfelt welcome. May we have the seats there, sir, gentlemen? Yes. All right, to take forward the proceedings of this session, I would now like to invite the session chairman with a BTech in Polymer Science and Technology. MTech in rubber, he has had a long span of 35 years in the industry. He has represented AIRIA to Bureau of Indian Standard BIS in committees BIS PCD 13 and 29 for rubber and rubber products and rubber testings, and also to ISO TC 45 committees. He has been a member of BIS PGD 40 on conveyor belts and also ISO TC 41. He has been a faculty member of IRI, American Chemical Society, ACS. To his name are the publications about reducing uncertainty in pipe conveyor designing with belt testing in bulk solids 2016, challenges in material handling system, NRC 2018, sustainability in material handling system, conveyor belt in IRC 2022. Ladies and gentlemen, let's put our hands together for Vice President Technical and R&D of Oriental Rubber Industries Private Limited, Mr. Chinmoy Ray. Can we have a huge round of applause for Mr. Chinmoy Ray? Heartfelt welcome to our session chairman, our first session of the day, and may I request sir to kindly come, take on the stage and introduce our speakers. Mr. Chinmoy, so may I request to kindly come to the podium, and yes, I hand it over to you from here. Thank you so much, sir.
Namaskar and good morning. We are on the 3rd day of our technical session, and this is the first session where 2 speakers will be presenting their papers. So let me take the privilege of introducing our first speaker, Mr. John Kaunavis. Mr. John Kaunavis holds a BSc in Material Science, Mechanical Engineering. He has over 30 years of experience in rubber industry, more specifically in the application and development of rubber compounding, processing, and predictive testing. His career includes roles of such as material engineering at Pirelli Tires, lab manager at Hankook Tires and Chemtura, technical service scientist for rubber chemicals in Uniral Chemicals, senior scientist for rubber sealant at Momentive, technical service manager at Dynasol, and now senior technical service manager at SI Group for rubber tire adhesives, SI Group Global Headquarters. Such an illustrated career, he will be presenting a paper on biosourced rubber curing ultra accelerator for tire and technical rubber goods applications. So I welcome Mr. Kaunavis for presenting the paper, and I'm sure we'll be greatly getting more information from him.
Thank you. Thank you, Mr. Harris. Thank you very much. I think there is a pointer or something to advance the slides. Thank you. Pointer. I'm not sure. Okay, well, we'll just have to thank you for the invite to the opportunity to present at this wonderful India Rubber Expo. It's my pleasure to be here. What I would like to do today is introduce one of our products. It's an ultra accelerator, a secondary accelerator, which is biosourced material. It's part of our development and effort on the sustainability aspect of introducing sustainable products to the market. The title of the paper, of the presentation, is called Biosourced Rubber Curing Ultra Accelerator for Tires and Non-Tire Technical Rubber Goods Applications. So the agenda I would like to cover today, it includes an introduction of SI Group. We will also give you an overview of our offerings for sustainable mobility and our targets. And then a brief review of the traditional rubber curing accelerators, and then the introduction of our product with some application data that we're going to review, and the conclusions. So SI Group introduction, we are a leader company, global company in performance additives, innovative technology. We provide to our customers and process solutions for performance additives and chemical intermediates as well, some pharmaceutical ingredients also. We are driven by value in enhancing the quality, performance, and durability of our products' contributions to the customers. The three business segments. The two biggest ones are in the polymer solutions and industrial solutions. We also have a pharmaceutical division. We operate under the polymer solutions because our material is providing durability, sustainability, and application performance for polyolefins, polyurethanes, rubber, adhesives, and upstream elastomeric components. Our global footprint with respect to sales offices, tech centers, and manufacturing ranges across the globe. Obviously, the global headquarters are now in the Woodlands in Texas. And then we have very good, strong manufacturing in the US for resins and anti-degradants. In Europe as well. In India also, we have a very good presence with our local office, and also our manufacturing sites here, and then in China. The company originally, Schenectady Resins, goes back to the late 1800s, when it was developed in upstate New York in Schenectady. Over the years, it transformed some acquisitions and some growth of the company. The key point here is in 2018, the company, the rubber additives products was under Adivant, and Adivant and SI Group belong to the same capital group, and then it were merged under the SI Group. So now SI Group has the responsibility of also the anti-degradants ranging from aminic, phenolic, phosphites, UV stabilizers, and some specialty products as well, on top of the resins, the Novolac resins. Sustainable mobility, obviously everybody, that's the big item of discussion nowadays. Everything is about sustainability, improving sustainability. People have aggressive targets with respect to 2030 and 2050 deadlines, or at least targets. In our offering for our rubber and adhesives products, range between tire and non-tire on the rubber side. And obviously tire is a big component, but also the non-tire side is, the different applications that we cater to range from anywhere from durable goods, industrial products, transportation, other the hood components, building and construction. So it's very, very wide range of product applications that our products go into. Our sustainability approach to sustainability is sort of like we have a 2030 target, which is very realistic and pragmatic, and we focus on operating, with continuous improvement in mindset. We're looking at sustainable practices within our own businesses, as well as product development, and then committing to credibility and transparency as well to our customers. 2022 ESG report has been presented already under the GRI Sustainability Reporting Standards. And our key focus areas, obviously, for our sustainable development is focused on 5 items: climate change, environmental impact, safe operations, a big one, diversity, equity, and inclusion, sustainable procurement, and then last but not least is our offerings, is sustainable innovation and business practices. So the 5 things, again, for the target, sustainability target by 2030 for SI Group is, first is the reducing of the carbon black emissions intensity by 25%. Introducing sustainable water management systems and water metering at all sites, at all our manufacturing sites, with the target to reducing the high water stress areas. Increase the number of women in management positions globally to 35%. Cover more than 95% of direct spend with sustainability evaluations, and reduce waste intensity through our process efficiency and improvements to beneficial reuse by 10%. So part of that deriving is already some products that we're working on. Just want to outline before we get into the bio-based material accelerator. We focus on eco-friendly solutions. We have now low HVAC. Also, pretty soon we're going to be introducing to the market an HVAC-free Novolac Tackifier resin. And ultimately, following thereafter, we're going to be starting the biogenerating, biosourced material for generating a tackifier. 50% is generation 1, 100% will be generation 2. We have already a product in the market for replacing resorcinol. It's resorcinol free for bonding. And then we'll talk about our bio-based material. So the traditional rubber curing accelerators, sulfur cure based, we all pretty much know the primary accelerators do not generate any nitrosamines. They're safe. Nevertheless, none of them are biosourced. The 2 biggest families that are very common is the thiazoles and the sulfonamides. DPG is there as well for the purpose of silica, for the silica compounding. DPG, it doesn't have any nitrosamine, but it has a lot of regulatory now issues, and it's a product of HVAC concern. Then the secondary is things like tetramethyltherm disulfide, tetraethyl, tetrabenzyl. These are all non-biosourced material, but at the end, only one has nitrosamine safe behavior, which is the tetrabenzyl. Tetramethyl, tetraethyl is nitrosamine generating, and also a lot of the sulfur donors, Something like dithiodimorpholin, as we know, is a very strong sulfur donor. However, it is very bad for nitrosamines. So our new biosourced curing accelerator is, starting material is liquid, 100% active material is liquid, semi-viscous. It is 85, based on 100% activity, it's 85% biosourced raw material based, and because of its high molecular weight and non-volatility, it is nitrosamine safe as listed by TRGS 552. Also, the starting amine is a very safe product as well. So when you look at the chart of the generation of the BioXL with respect to boiling point, you can see very clearly that it's in a non-volatile region and the boiling point is above 300 Celsius. Some of the other amine generating material like the tetramethyl dithiodimorpholin, they're very, obviously they're below that and very volatile, and that's how the secondary nitrosating agents are formed. The product, we'll cover some of these key properties as far as rheology and tensile properties and some dynamic evaluations as well. This product by nature has a different, it has a masking capability of reducing the sulfur odor smell in the compound, and also has been seen to eliminate or reduce the blooming effect, especially for EPDM compounds for sponge, closed cell sponge applications. So one aspect that we started looking at is for silica, high silica compounds, tire, tread, and some other applications. Where DPG now, you can see, has a very high regulatory concern. It is, has all these classifications that you see on the left-hand side. And the GHS classifications, you can see on the fourth bullet down, it's a reproductive toxin, category 1B. And it used to be on the French authorities, they have categorized it as such. Now the German authorities have picked up on this. Our understanding is that DPG in the next 2 to 3 years will be top 5 target chemical for elimination in the EU, according to ECHA. Also DPG, unlike the perception that during the reaction in the compound, the DPG completely is completely used in the process. When they did some particles of rubber compounds and they did a water extraction, and they found that it is present as its form, as DPG. It's not fully reacted, as many people believe. So we did a study and we looked at some silica thread particles. We did the water extraction, and we found that indeed the same, that DPG after the water extraction is present at 3.6 ppm. In the composition is about 0.81 of the rubber composition, and the Nogar BioXL at 0.41, and you'll see a little bit why, because Nogar BioXL, to replace DPG, it can be a lot less than the DPG level loading. And the Nogar BioXL is non-detectable. It's at below detection limit. So we start first with a silica thread compound. And we want to look at, obviously this is a high silica loading. You can see it's 100 pHr of silica. And it has some blend ratios of polymers targeting like an all-season thread performance. We did not include any plasticizers here or anything more than just trying to keep it as basic, and wanted to see the effect of the switch out between DPG and an Nogar BioXL. Key indications here is, we did this in an internal mixer at 1.6 liter. We included a 3-minute heat treatment at the end of each pass in order to be able to ensure the complete salinization. And the two BioXL components that we looked at is, we look at the dosage of 25% of the DPG loading and then up to 50% of the DPG loading. Obviously for high silica, as the silica amount increases, DPG increases. In this case, we use 2.2 pHr of the silica. On the cure curves, you can see they're not fully optimized. We're getting some marching modulus. You can see very easily that the DPG has almost very little induction time. It is very quick, and it is also some flocculation effect for all compounds. However, the DPG, the BioXL substitution shows some potential improvement in induction time. The final compound Moonies were about 80 in the lab scale, can be a little bit lower. This is where the processing additives come into the picture. And then the target compound TGs were about -30 to -32, which was our original target. When we look at the uncured G prime as an indication of bin stability, the product after day 1 was pretty level. 3 days as well, we had some values that were pretty level. Then we took the compound on bin stability measurement after 7 days. This is where, you know, the Mooney increases. The more the uncured compound is lays out on the open storage area, the reagglomeration and the Mooney viscosity keeps on increasing. So we see a little bit of an increase with the BioXL. However, this is, in terms of translating it to Mooney units, is not that significant. Regarding the cure properties, you can see that the lower dosage of BioXL has equivalent performance with the DPG. And then when you increase more on the BioXL content, you're reducing a little bit of scored safety and reducing the cure rate as well further. Maximum MH torque is standard. This is to be expected as you increase the disulfide by replacing a non-sulfur donation accelerator. You tend to see this kind of effect. So if you need to go to a higher BioXL or any other thirium disulfide level, you have to consider the sulfur contribution and adjust the amount of neat sulfur to have balanced properties. Nevertheless, the effect is apparent on the tensile properties. The solid lines indicate the comparison between DPG and the 2 levels of BioXL. 25% of the BioXL traces very close to the DPG as a replacement, only a quarter of it. When you go to 50% now, it's again that introduction of mold sulfur into the interface between the polymer and the filler. It's a sulfur donation system. So what happens is your modulus increases, modulus 300 goes up, looks like your reinforcement is improving. However, you have to take that into consideration because you're losing on the tear and tensile properties as well. After aging, the properties are pretty balanced. It's only 3 days at 100 C, very aggressive. However, you can see on the right side, the tensile times elongation, the retention properties are very similar, slightly lower with the 50% BioXL dosage. Now, what you expected to happen is the dynamic properties, the hysteresis will improve as you increase the sulfur donation going from 25% to 50%. Again, if you want to maintain tear and tensile and improve those properties, you have to make some adjustment on the total sulfur level. And here you go. This is the dynamic property second strain sweep at 60 degrees Celsius. On the left-hand side, you're looking at the delta G prime from low to high strain as an indication of pain effect, or better, lower the value means better polymer filler interaction, lower polymer filler interaction, higher polymer filler interaction, lower filler to filler network. So the 25% shows slight improvement because you're getting a crossover compared to the DPG, and it's really maximized when you go to 50%, you have even better properties. And that shows when you look at tan delta max, about 5%, strain, you can see that even at 25%, all things are equal, you're getting a reduction in tan delta, which means improvement in hysteresis, and then even further improvement when you go to the 50%. Looking at a strain sweep in terms of traction performance for tires, you know, we tend to look at low temperature properties. We tend to look at any shift towards the 0 degrees for wet traction, and then stability between 25 and 60 degrees Celsius. You can clearly see here that there is a shift as well on the curves. You have an increase, which again indicates that polymer filler interaction advantage. And the slight shift is probably coming from our product is a very high molecular weight, about 900 molecular weight, has very long alkyl chains. It does create some entanglements. It allows you to give that flexibility for the tensile properties, but also may contribute a little bit as well to the shift, which is desirable because if you translate this to a summer tire, you will be able to gain at 0 with wet traction performance. In this case here, this indicates as a possible improvement for low temperature properties like ice and snow traction. So one thing that a lot of people in the industry say, for this kind of application is the moment you replace DPG, you're going to lose wear. There's the one aspect is the tensile properties, which will show that it can be the same, but then what happens with wear? Our way of measuring that is by Dean method in the lab, and you can see on the left-hand side that we're getting about 10% better Dean mass loss compared to the DPG, so that's improving by 10%. So in my opinion, this is an indication that there is a long way from correlating a Dean abrasion to actual road tire wear. So a 10% improvement gives a sort of a peace of mind indication that it should be similar in wear and can be tested for a road test. At the same time, and this does not change as the reinforcement increases as well. You can see that between 25 and 50%, it remains the same at 10% improvement. When you look at 10 delta max versus the ratio below is the static slope of the strain, the stress strain curve over the pain effect, the delta G. That's an indication parameter, interaction parameter. Typically for silica silane coupling systems, if you're getting 40–50% better, that's an indication of very good durability and long-term better wearing compound. And you can see that 10% you're getting improvement from overall from just a direct replacement of 25% of the DPG, and then you're really maximizing at about 60% on the interaction parameter and 22% improvement for hysteresis. So an overall scheme of the lab data, it shows that the 25%, the green one, traces very nicely replacing DPG, with some improvements in certain areas, including rolling resistance and possible wear and abrasion. Then when you want to maximize certain properties like rolling resistance, for example, hysteresis, you can go to the 50%, but you do need to make that sulfur adjustment because you don't want to lose your chunking or tear properties. And yeah, so that's the target for replacing DPG. There's only one parameter here that is missing beyond that we're going to test in an outside lab. We don't have the capability, and that is the durability, the fatigue to failure test. Typically in fatigue to failure, you do kilocycles to failure, and then you age the material and you measure the retained properties. It's the most important thing, to measure the retained properties versus the control and see how close your material behaves. Because this is disulfide introduction, you're using an S4 type of silane, so the system gets very heavy on the sulfur donation, and the more you go into the polysulfidic cross-linking distribution, you are improving these properties, but you have to keep into consideration your heat resistance and heat aging properties from the static mode. So then we're going to switch gears a little bit to look at a couple of different non-tire recipes. And the first one is sort of a generic radiator hose, which has DTDM and TMTD as a strong sulfur donor. DTDM is one of the best sulfur donors in the industry, as you may know. This system is it's a semi-efficient, very low sulfur system, and has a lot of nitrosamines there between the TMTD and the DTDM as well as the ZDBC. Ideally for the dithiocarbamates, the zinc dibenzyl is the safest one, but in this case we have the generic form and we use that. The second compound, you can see it's taking out both DTDM and TMTD and just putting BioXL at 8 PHR, 100% active. On the third one, we just wanted to look and see what happens if we just replace the TMTD and leave the DTDM in there. And the final one is a modification for a system that should match the properties, and it's completely, should I say, nitrosamine safe, with the exception of the ZDBC. That can be replaced with the zinc dibenzyl. So clearly you can see that the control is the gray line, and then when you look at the BioXL, the orange line, replacing both DTDM and TMTD, is not quite there on the cross-linking because it's much lower. You're always going to see that the BioXL is going to impart a lot of scored safety, okay? So then when you look at the BioXL and DTDM, it comes up a little bit on the blue one. You do have some scored safety. but we're not quite there on the matching of the maximum torque. The green line is the one that's completely nitrosamine safe with the BioXL, and you do have options. You can use the caprolactam, the thiodicaprolactam, and the MBT to match the cure rate, so that's relatively close. Looking at the properties, of course, you look at the control, 300% modulus, unaged and after aging at 125 degrees Celsius. You can see that the second one, the BioXL, is lower starting, but it has also the delta of increase is much lower. That's what the BioXL does. And when you look at the final compound, which is adjusted to match the nitrosamine safe component, is very similar to the control, maybe slightly less on the modulus build, which is desirable. When you look at the tensile times elongation, obviously the best one of these will be the second one. You're going to have the biggest impact on that after aging as well, but you have to consider that your modulus is lower as well. So you're getting more of a gummy compound breaking higher. The last compound is the one that you have, if you compare the last one to the control, you can see that the original tensile elongation performance and unaged and aged is better than the control. So that's definitely the right direction for the compound. When we look at Sure versus compression set, very clearly you can see that compression set, with the exception of the third one, and I'm not sure what the contribution may be there, or if it's just an outlier on the testing. Nevertheless, when you compare the nitrosamine generating control versus the non-nitrosamine, you can see that the Sure is more stable after aging. It doesn't increase as much, which is good. You're not getting the hardening effect. And the compression set is comparable to the control. So it's definitely in the right direction for a consideration of this product replacing as a product that maintains the tensile properties after aging, maintains compression set, and contributes to some effect with the sulfur donation. Not to replace both TMTD and TDM, but partial replacement. So then we went ahead and looked at a natural rubber, low filler, generic recipe, kind of recipe used for toys, dog toy applications, things of that nature. And you can see that in that case we have both TPG at low level and TBZTD. So we wanted to replace both of them, and we did 2 levels of BioXL at 0.6 and 0.8. And you can see the blue curve at 0.8 is closer to the control, which is in the right direction. Then looking at the properties, the Sure before and after aging is very comparable to the control, maybe a little closer increase, but not significant. 300% modulus as well is lower. So you can see the effectiveness of BioXL. At the lower level, you're getting a good response immediately with the properties, not stiffening the compound too much after the aging performance. Tensile elongation as well is the last one at 0.8 is closer to the control because it starts at comparable level, and after aging, it's a little bit higher as well. So it does retain the properties, and this product can effectively replace in these applications DPG primarily, but also another product like a TBZTD. Looking at a nitrile, generic injection molded application, had a couple of requests to look at a recipe with TMTM, the monosulfide version of the tetramethyl material, and then replace DPG as well. So we looked at against the TMTM, which if you may realize, and you can see it on the cure curve, that is the only product that will give you that kind of cure rate and maximum MH because of its activation compared to any other type of secondary accelerators. TMTM is also a very bad product with respect to SVHC and regulatory concerns. So what we did was just replace it at equal parts and looked at it, and it's obvious that you can see the blue line. It needs some kind of activation further to match the TMTM performance because you get much longer elongation, scored safety, and the MH is lower. When you look at the DPG replacement in this case, you can see that at half of the dosage of DPG, you're having a much longer scored safety, and the MH is lower, a little bit lower, so some adjustment needs to be done with respect to the MH, but the scored safety certainly allows you flexibility of, curing at a higher temperature or, doing some other stuff with the primary accelerator. And then when we look at the physical properties of this product, you can see that the 100% modulus delta for the second and the fourth compared to the first and third controls is less, which is in the right direction after aging. You can see that the compression set for both sets, TMTM versus the BioXL on the second, is lower. Also, the aging properties are less for the Shore A, and then also the same thing for the DPG. So overall, in the right direction of improvement of, especially after aging, maintaining very good properties compared to a control. Tensile elongation, you can see the two highest ones, both unaged and aged, they're all based on the contribution of BioXL. This is exactly what that long alkyl chain entanglement does before and after aging.
PUSG has arrived.
Okay, conclusions.
So, yeah.
But pretty much this product is obviously 85% biosourced material. It is a thiram disulfide. It is very effective in, especially for maintaining the physical properties after aging. It does provide dynamic performance and hysteresis improvement. It is, compared to DPG, is much safer, and it's available. It's available for evaluations on your specific compounds. And that's it. Thank you very much.
Thank you. Thank you, everyone.
Yeah.
There's an announcement. Thanks. There's an announcement that PUSG is with us. So we'll be resuming this session after his visit. So be patient and be with us. So we are leaving the dais and we'll be reassembling again after his visit. Thank you.
Thank you. Thank you so much, Mr. John Konavis, for the wonderful session. And we would be resuming our other two speakers' session very shortly. Ladies and gentlemen, it's an absolute delight for all of us present here at IRE Mumbai 2024. And with immense honor, my dear friends, let me announce the gracious presence of our chief guest, Shri Piyush Goyal ji, the Minister of Commerce and Industry, Consumer Affairs, Food and Public Distribution and Textiles, Government of India, and leader of the House in Rajya Sabha and India's G20 Sherpa. Ladies and gentlemen, let's put our hands together and welcome our honorable chief guest today, Shri Piyush Goyal ji. have mentioned that we are immensely honored, really grateful for the gracious presence of our chief guest at IRE Mumbai 2024, Shri Piyush Goyal ji, the Minister of Commerce and Industry, Consumer Affairs, Food and Public Distribution and Textiles, Government of India, and leader of the House in Rajya Sabha and India's G20 Sherpa. My dear friends, can we have a huge round of applause for our honorable chief guest, Shri Piyush Goyal ji. Heartfelt welcome, sir. We are immensely honored, and here I also welcome our three dignitaries of IRE Mumbai 2024. We welcome here Shri Vishnu ji, we welcome here Shri Shashi ji, and Shri Vikram Makarji. Well, my dear friends, ladies and gentlemen, as we have been saying that yes, it's an absolute honor, and it's extremely wonderful of Shri Piyush Goyal ji for taking time out of his busy schedule and gracing us with his presence. And as we also say, flowers and mementos are our way to express gratitude and respect. And therefore, I request Shri Vishnu Bhimrajka ji, Chairman and Chief Convener, IRE 2024, and Director of Poleman India Limited, Shri Vikram Makarji, Managing Director of Oriental Rubber Industries, and Shashi Kumar Singh ji, Director and Technical Head, Osaka Rubber Private Limited, and President AIRIA, to welcome and honor our esteemed chief guest with a flower bouquet, shawl, and memento. Ladies and gentlemen, can we please have a huge round of applause for our chief guest, everyone? Yes, and the moment of felicitation has arrived. It's now time to present a token of love, the token of respect to our honorable chief guest, Shri Piyush Goyal ji. May I request Mr. Vikram ji, Mr. Shashi ji, and Mr. Vishnu ji to kindly do the honors. Ladies and gentlemen, while our dignitaries are doing the honors, can we have a huge round of applause, please, everyone? Thank you so much, gentlemen, for doing the honors, and thank you so much, Shri Piyush ji Goyal, for honoring us with your gracious presence once again. Thank you. And it's now time to take our proceedings further. May we welcome on dais Vishnu Bhimrajka ji, Chairman and Chief Convener, IRE 2024, and Director of Poleman India Limited, astute leader with a huge round of applause. Ladies and gentlemen, can we hear it out for Mr. Vishnu Bhimrajka ji? Heartfelt welcome, sir.
Good morning. We are all excited and delighted to have Honorable Minister of Commerce and Industry, Textiles, Food and Distribution, Shri Piyush Goyal with us today. So I would want again a big round of applause for him. Thank you, to come here from his busy schedule at a very short notice. And we are delighted to have him because he's a visionary. He has been working very hard for a couple of decades, I would say, even before 2014. And as a Commerce and Industry Minister, he has played a very pivotal role in enhancing the Indian economy under the visionary Honorable Prime Minister Shri Narendra Modi, that we are today from an economy position of around 10th globally before or around 2014 to 5th largest, and which is, I think, a humongous achievement. So a big round of applause there too for this government. Yeah. And we all in the rubber industries are truly, very optimistic and excited because rubber as a product in some form of components, etc., are used into various sectors across the industry. May it be defense, all three defense forces, may it be our space program, may it be our mobilities like the railways, automotive, consumer electronics, durable, all your health, food and pharma, even in the textile, for the textile mills, when they use rollers, in the food processing, when they use the rollers. You look at footwear industries, you look at power, where a lot of wire and cables are being used, even in home furnishing, etc., where we have adhesives. So infrastructure, whether it is our bridges or commercial establishments or residential buildings. So rubber in some form of a component is inevitable, and it is used in almost every sector. And Indian economy, which is poised to move forward from the 5th position amongst the top 3 in a very short period of time, I'm sure the growth across the sector also means that there is a growth for the rubber industries per se. Rubber is just not natural rubber or just not the tire part of it. Yes, that's one application which is significant and which has to grow, but 40% of the rubber which is being consumed here in India is for non-tire applications, so which includes synthetic rubbers and of course some natural rubber put together. So our vision and this Expo brings a platform where we have grown since year 2001 from the current position as the largest rubber expo in India. We will have vision and guidance from Shri Piyush Goyal about the India Rubber Expo and how we can shape it up and make it more meaningful and more interesting on a global platform. So I would rest my speech here, and once again a big round of applause for our chief guest today, Shri Piyush Goyal. Thank you.
Thank you so much, Mr. Vishnu Bhimrajka, for the wonderful insights that you have shared with us about the industry and about the economy. And yes, my dear friends, as we all know that this is the moment of glory which will be carved in all our hearts forever, because yes, we have the gracious presence of Shri Piyush Goyal here with us, and all of us are extremely excited, are really happy to hear a few words from Mr. Piyush Goyal. So ladies and gentlemen, can we have a huge round of applause for one and only one, our chief guest, Shri Piyush Goyal. Welcome, sir.
My good friend, Shri Vishnu Bhimrajka ji, the chairman of the organizing committee and chief convener of IRE 2024, Mr. Vikram Makkar, past president of ARIA, Mr. Shashi Kumar Singh, president of ARIA, distinguished ladies and gentlemen. I know this is a very last-minute visit. I was in Delhi and not slated to be in Mumbai, but was able to make a program at the insistence of Vishnuji and his family, and we share such a long history together that it is not possible for me not to accept a Bhimraj ka request. And I'm really delighted I'm able to come here and share some views, particularly since I can see the rubber industry playing an increasingly important role in the years ahead. While we are all tied up with the elections, there is a model code of conduct which also restricts a lot of what one can share with you about the huge plans that we have for the industry, for all of you. I couldn't help but notice that I was welcomed by a saffron shawl. I don't know the significance, whether it was selected particularly because I was coming, or all your guests were welcomed with a saffron shawl. But well, the mood these days is such that possibly if you had welcomed all your guests also with a saffron shawl, they would have been very excited about it. I must share with you before I go further another reason why I wanted to be here, because your industry comes directly under the industry ministry, DPIIT. And I also have the rubber board under the Commerce Department. And personally, I think a collaboration between the rubber growers, the MSME sector in the rubber industry, and the large players is the need of the hour. Over the years, we have all been working in silos. We have the rubber board which has a certain mandate and is focused totally only on the rubber growers with very small targets and small ambitions. We have the Tire Manufacturers Association on the other end of the spectrum, a club of a few companies, large companies, focused only on automobile tire manufacturing. And then we have the rest of the industry fragmented. Somebody is a Cycle Tire Manufacturers Association, somebody is Rubber, Electronics Rubber Parts Association. We are pretty much out of sync with the way the world works today. And we in the government also are focused on breaking these silos and looking at, just like Prime Minister Modi looks at whole of the government or whole of the nation when he's making public policy, we are now trying to look at whole of the industry approach in whatever activities we take up. It is in that spirit that the entire mobility sector, end to end, came together on one platform under Bharat Mobility. I don't know if any of you had the chance to visit Bharat Mobility. It's probably the largest show that we have ever had in India in the mobility space. Probably also the only show we've ever had in India, where even the steel industry was present, where NASSCOM was present, with the growing influence of electronics and software in automobiles and other mobility-related activities, where we had ACMA, the component manufacturers, ATMA, the tire manufacturers, and the entire spectrum end-to-end, be it design of cars and automobiles. Many companies, I'm told, participated for the first time ever, even amongst the various mobility sector companies. So out of the 15 or 20 large companies in the automobile manufacturing space, commercial, two-wheeler, three-wheeler, four-wheeler, material handling, even amongst them, I had a list of half the companies who had never participated in any exhibition. They never valued the importance of showcasing the India story. And when we conceptualized Bharat Mobility, and I insisted that it should be an end-to-end affair, there was quite a bit of resistance. And we saw the same thing happening in textiles. Bharat Tex is the world's first end-to-end exhibition and conference of the entire textile sector. It has never happened in the world before. We had cotton growers, we had the chemical industry providing chemicals and dyes to the textile sector, we had machinery manufacturers, we had man-made textiles, synthetics, technical textiles, cotton, khadi, the entire space, and handicraft and handloom also. It had two large venues, Bharat Mandapam and Yashobhumi, fully booked up. So much so that when we made these large exhibition centers, and together these two are over 2 million square feet, they were fully booked from 3 months ago when the industry was saying we'll need at least 1.5 years to prepare. Within 3 months, not only did they pull off a big success, but it so happened that we had to once again bring back tents into into Bharat Mandapam. जो टेंट से निकालने की कोशिश की थी बड़ा विशाल भारत मंडपम बना के, वो पूरा यूज होने के बाद फिर हमें 4 हैंगर बनाने पड़े to accommodate the demand. And we had people calling my office, I've got 20 square meters or 40 square meters. Can you help us increase the area? That was the level of demand that was generated. And everybody, in fact, they had a celebratory dinner 3 days ago or 4 days ago in Mumbai, celebrating the success of Bharat Tex. And they've already decided to make it an annual affair. And next year's dates have been finalized. Mobility also plans to do it every year. Day before yesterday, on the 20th, one of the reasons I couldn't join you for the inaugural, Prime Minister Modi inaugurated the world's largest startup conglomeration of companies in deep tech, AI, in fintech, agri-tech, biotech, medtech, the entire spectrum. Nearly 1,500 startups in one place at Bharat Mandapam, with nearly 70, 80 conferences and seminars. And I must share with you, at the inaugural, we had it in a large plenary hall with 3,800 or 900 capacity. Of course, that got filled up by 9 o'clock for a 10:30 arrival of Prime Minister. There are 2 other halls in Bharat Mandapam of 1,500 people. Those also got filled up. And there were 4,000 people outside who could not even be allowed to enter into Bharat Mandapam, into the main conference venue. तो 3,800 की कैपेसिटी के प्रोग्राम के लिए nearly 9,500 people landed up. Startups की दुनिया में ये हो रहा है, ये excitement है. The youth power that I saw there was truly amazing. As Prime Minister said, the vibe of that program was unbelievable. I'm sharing this with you, friends, because I see that same potential in the rubber sector. The tire manufacturers are, of course, supporting an initiative to promote new rubber growth, developing new natural rubber growth opportunities in the northeast, in Kerala. They are investing about 1,080 crores to expand the rubber production in India. But I genuinely believe that a country which is already importing 5,000 crores worth of rubber, by the time we go into the next decade, let's say in the 30s, 2030 to 40 period, we will need 40,000-50,000 crores of rubber imports. That is my estimation going forward. And therefore, I believe that each one of your exhibitors should today be looking at the India of 2047. You should be looking at Viksit Bharat 2047 and where India will be with a $30 trillion plus economy. What your sector will be in an economy which will be 10 times today's size. What role you will be playing when India produces 10 times the number of automobiles that we do today. Just imagine the pace of development of housing, the pace of development of industry, the demand, the growing demand for rubber in a variety of ways, including possibly, I think, a simple thing like the yoga mat. With the International Day of Yoga, now increasingly taking yoga to the world, just rubber mats required for yoga will be a huge demand. I'm taking the simplest and most elementary item where rubber is going to be used. Every automobile will need increasingly more rubber parts as they are trying to reduce the weight for electric mobility. Battery being an expensive product, every kilo of weight reduced in an automobile is top dollar for the automobile sector. Will add billions of dollars of value to the automobile value chain. So imagine what you can do. And with synthetic rubber and natural rubber both getting together on one platform and offering to the world high quality products, innovative solutions for the problems of the world. Can you imagine where each one of your business can reach in the next 20-25 years? And I would personally think, while this exhibition is being held after about 4 years, we should be looking at an end-to-end integration, big, small, micro, all coming together. The entire value chain being captured. We should invite participation from all over the world for people to come and demonstrate their products also. Don't worry about the competition. India has the capability to compete with anybody in the world. We have the best of talent. We have the best of technologies. What we don't have, we are willing to invite to come to India to manufacture. Investors are queuing up to invest in industry in India because they recognize that India can be a trusted partner. India has the rule of law. India respects patents and technologies. India doesn't steal somebody else's technology like some countries do. And our management talent is superb. Our workers are very skilled and hardworking. Cost of production of goods and provision of services in India is competitive vis-a-vis any other part of the world. What we need is economies of scale, a dash of sustainability added, and we need to ensure that we produce highest quality product. India should create a brand equity, a recognition that our products are high quality. And Prime Minister Modi, way back in 14-15 itself, had offered to the nation his vision of Indian manufacturing. Zero effect, zero defect, Z. आपको याद है कि नहीं? उन्होंने जब Z का concept introduce किया था. Our businesses should have the least impact on the environment. Our manufacturing processes, our footprint, carbon footprint, through our cycle of production or consumption should leave the lowest carbon footprint, should have the lowest impact on climate change, while at the same time, our quality should be the best in the world. We, in a small measure at the Bureau of Indian Standards and the Department for Promotion of Industry and Internal Trade, collectively are working to bring the culture of quality in India. The Quality Council of India, QCI, has also made significant impact in its own way in creating a greater awareness and bringing to the fore the importance of quality. Sometimes I feel industry is not taking as much a proactive action or involvement as you should, whether it is in the setting up of quality standards, whether it is in supporting the small suppliers to help them understand the importance and value for quality. We have technical committees in BIS which formulate standards. I urge industry for a greater participation while formulating standards. I want the demand for quality standards to come from industry. I want each of you to help us formulate what is it that will define India as a brand you can trust as quality which is the best. I want you to help us bring in quality standards, possibly horizontal quality standards, which will help you provide safe products. I want you to help us and guide us on what should be the standards which will define the good quality of raw material that your industry demands or requires. And if we work together as partners, if we work together as equally responsible stakeholders, I have absolutely no doubt in my mind that Asia's largest rubber expo can, in the year 2025, next year, become the world's largest rubber expo. I have absolutely no doubt in my mind that you will not have to invite buyers from only the neighboring areas of Bangladesh and Nepal and Sri Lanka, or even possibly from Africa, by paying them an air ticket and hotel accommodation, which sometimes many of our associations do. Rather, we should make it a compelling reason for buyers from all over the world to come to India, with 100 countries participating even as exhibitors. Let's showcase to the world at one place the entire world's capabilities, and within that forge new partnerships, forge new collaborations. Let the other exhibitors who come here see India's strengths. Let Indian industry recognize your competition. And just like many of us rush to go to Hanover or other trade fairs, the world should rush to come to India, because at one platform, the whole world will be available here. Think about it, reflect on it. Why do we go to Hanover? Because we feel at one place, every player from all over the world will be available. So we won't have to go to 10 exhibitions in 10 countries. We just go to one and we'll see the entire competition, machinery manufacturers. We will meet with those who produce the same products we do. We can see what is their differentiating factor. We'll get an idea of pricing. We'll meet other people from across the world who are coming there as buyers. There's a variety of benefits that we see. Can we not provide all those features in India? Because the epicenter of the world is moving away from developed world to a developing country which is aspiring to become a developed country by 2047. The opportunity is in India. The world recognizes that. I think we don't recognize our own strength. And my purpose of joining you today was only to, in a way, repeat Swami Vivekananda's words, rise, awake, and rest not until you reach your goals. The nation's goal has been made up. The nation has made up its mind. भारत अब निकल पड़ा है. दुनिया की कोई ताकत भारत को रोक नहीं सकती. No power on earth can stop India from becoming a developed nation by 2047. It's the collective vision of 140 crore Indians. 1.4 billion Indians have resolved that we will do our best and make India a developed nation. Our time has come. You have to choose where you see yourself, your company, your business, your family in this journey. And I have no doubt in my mind that the rubber industry will be left behind as we move forward in this journey. And I can assure you that India will stand for high quality. India will stand for equal responsibility when it comes to sustainability. India will stand for high quality sustainable products at affordable prices. And not only will India be able to meet the large growing domestic demand, whether it's in the electronic space, whether it's in the machine space, whether it's in the automobile space or construction. I don't know how many other sectors your industry must be servicing, but personally, I would suspect there would be no part of our life where rubber doesn't play an important role. Absolutely nothing. And I do hope to see an end-to-end integration. I'm seeing even here in amongst your sponsors, people from the textile industry also have a stake in rubber. I can see so many other sectors which normally one would not imagine has any stake with the textile sector. Chemicals I see has a significant stake. Oil sector has a significant stake with your industry. और फिर दिमाग लगाते हैं तो क्या नहीं समझ में आता है. हवाई जहाज में कितने रबर कंपोनेंट्स होते हैं. Every aeroplane has so many rubber components. I suspect the military must be having defense, would be having a lot of demand for rubber products. आप कोई क्षेत्र देख लें, आज यहाँ पे भी जो ये पूरा कॉम्प्लेक्स है, इसमें सब वॉशर्स तो रबर के ही लगे होंगे. इलेक्ट्रिकल इंडस्ट्री में सब रबर के इक्विपमेंट काफी लगता है. So the world is your stage, the world is your market. India will of course continue to be a very fast growing market. But I do hope you will not restrict your vision only to the high growth India story. We should be aspiring to be a world leader. We should be looking at the startup ecosystem to also support us with innovative ideas, innovative products. Day before, Prime Minister gave a very good idea. Can we, whether it's MSME or the large industry, can we come up with problem statements? And everybody has one or the other challenge, one or the other issue that we are grappling with. I run an industry, so I know every day we grapple with a new problem, a new technical problem, a new operational problem. Can we have hackathons to encourage young men and women, young engineers, young scientists, young entrepreneurs, people with a vision to go out of the box, think out of the box, think uniquely different? Can we have hackathons where we present our problem statement and encourage young men and women to come out with solutions and use those solutions in our industry, collaborating with these youngsters, collaborating with these innovative minds? Because today, the nation recognizes that it is innovation, R&D, new ideas, which will power India's growth story. Our theme for the Startup Mahakumbh, another grand success. The first time so many sectors came together at such large scale. The theme was Startup Mahakumbh, Bharat Innovates. And I do hope the rubber industry will also take innovation as your mantra, new ideas, innovative ideas, new ways of working to scale with sustainable practices, high quality work. Let us all put our best foot forward, collaborate between different sectors related to your industry. Keep government out of your life wherever possible, but take us as facilitators only to support you, only to ensure an orderly growth and development of the industry, only to protect you from unfair trade practices, only to protect you from substandard imports which hurt your business and hurt your qualities. And let's together make rubber a growth engine of the Indian future, of India's economic future. I am very, very sure under the leadership of such dynamic industry captains, under your leadership and under the leadership of a visionary like Prime Minister Narendra Modi, who has set a very high bar for every Indian, for India, who has set very high ambitions, who told us in the last Council of Ministers that a model code of conduct doesn't mean government stops functioning. Government has to work at the same speed as normal times. Government has to work for the people of India, for industry. And secretaries were told you're not supposed to go and play golf because of the model code, since we'll all be busy in the elections. You have to prepare the roadmap for Vision 2047 during this period. And when Prime Minister Modi comes back in his third term, this country is going to see newer and bigger heights of growth and development. Thank you very much, ladies and gentlemen.
Thank you so much, Shri Piyush Goyal ji, for your valuable insights and the awe-inspiring words. I'm sure these words are going to stay with us and help rubber industry to grow in leaps and bounds. We are immensely grateful to Shri Piyush Goyal ji, our chief guest of the day, who has graced us with his presence. Ladies and gentlemen, let's have a huge round of applause. And can we have a standing ovation for Shri Piyush Goyal ji? Please, can we all rise up and give a huge round of applause to Shri Piyush Goyal ji? Thank you so much, sir. Thank you so much once again. Thank you so very, very much. I'm sure, as we have said this earlier as well, that this is the moment of glory which will stay in our hearts forever. It really swells our hearts with lots and lots of pride and lots of happiness. Indeed, the final day of IRE Mumbai 2024, and here we have the gracious presence of our chief guest, Shri Piyush Ji Goyal, here with us today. Thank you so much, sir. Once again, thank you so very much. And yes, ladies and gentlemen, once again, a heartfelt welcome to everyone. And we shall be resuming our session. I request everyone to kindly be seated. Yes, we started our session. We are done with our first speaker, but may I now invite on stage Mr. Chetan Bhangle, Mr. Sandesh Nandre, and Mr. John Kunavis once again on the stage, please. All three speakers, may I request your presence on the stage along with our session chairman, Mr. Chinmoy Ray, please. Welcome, gentlemen, once again on the stage. I request our audience, let's get seated. And yes, we are about to resume our session of the day. Thank you so much, Shri Piyush Goyal ji. Once again, sir, it really means a lot to IRE Mumbai 2024. Thank you so very much, sir, for your presence today. And of course, the wonderful insights that you shared, the knowledge that you shared, not just about the rubber industry, but the overall economy and overall our nation. Thank you so very much, sir, once again. And may I request our session chairman, Mr. Chinmoy Ray, to kindly introduce our next speaker of the session. Thank you.
What an impactful presentation, what an impactful lecture Piyush ji has given to us. And his positioning, India's positioning in the global forum is very well said. And he also talked about sustainability, and when I'm representing Bureau of Indian Standard, Rubber Technical Committee, and there is always a pressure to us in the technical committee to bring in more sustainability and make the standard which is defining a sustainable product and the parameters. So sustainability brings its circumstance, better standard of living, profitability, and protection of natural resources. And with this, it may be a very important for us, Mr. Kaunavis, if we can get some guideline on how we can have those kind of standards to make of various chemicals. Because in his lecture, what is the very important part, that he has proposed a product which is not only nitrosamine free, it is not only replace DTDM, DPG, TMTD, TBZDD, but also they are biosourced. So he has struck a deal with one stone, he has killed two birds. Thank you, Mr. Kaunavis, for your excellent presentation. Our next speaker is Mr. Chetan Bhangle and Mr. Sandesh Nandre. Mr. Chetan Bhangle is an associate TSD scientist at Dow Consumer Solutions, has a dual responsibility in catering mobility and transportation, along with textile and leather market across India, Pakistan, Bangladesh, and Sri Lanka. Chetan is associated technical professional with 22 years of diverse experience in the innovation, technical services, strategy planning, sustainability. A seasoned professional with expertise in spanning across various sectors, operations, and product lines like elastomers, emulsion, anti-foams, processing chemicals, dyes, pigments, etc. Embarked his professional journey in 2002 with the MBL Moraji Brembana Limited in Nagpur. Subsequently, he has moved to IFPL Indus Fila Private Limited, Hunt Suman, Atul, Dow, Corning, and Arvind Limited. In 2016, Chetan established in-house R&D unit recognized by DSIR at Arvind Limited, Santec, Marketing. Santec marking is significant stride in the company's innovation journey. He also developed in company's innovation journey. So he has a very illustrated career. Basically, he is a textile engineer and also having licensed technical chemistry from VJTI Mumbai. And another speaker from his organization is Mr. Sandesh Nagre. Sandesh Nagre is sales manager, mobility transportation, business and Dow Consumer Solutions, and recently added Middle East in his portfolio for his market. Sandesh is competent business developer, over 16 years of commercial experience in several markets like automotive, industrial, electronics, consumer, and solar. Sandesh has managed several product lines like elastomers, sealants, engineering materials, lubricant, and thermoplastics. So, Sandesh holds a BTech Chemical Engineering degree from the UDCT Mumbai and UDCT and NMU and MBA from Department of Management Science, University of Pune. I welcome both Mr. Chetan and Mr. Sandesh to present his paper. His paper is Innovations in Silicone Elastomer Technologies Addressing Sustainability and Challenges in Automotive, Consumer, and Aerospace Industries. Please.
Thank you, Chinmay. So, good afternoon, everyone. I welcome to our session. Myself, Chetan Bangale, and my colleagues, Sandesh Nandre, will take you through the various innovations with respect to the silicone elastomers that has been used in overall M&T space. So, this is the agenda where we will deep dive into the nitty-gritties of a silicone elastomers and various applications. We will start with the Dow product portfolio, selective adhesion LSR, low temperature cure products, LuxSense, then silicone self-sealing tire solutions, specific celastic grades for power terrain electrification and battery fire protection application. Then we will also move towards FSR or FLSR in automotive and aerospace applications. So before going into that, I will just want to explain you about Dow product portfolio with respect to the market and the sustainability strengths. Dow being the most innovative, customer-centric, inclusive and sustainably material science company, we have a unique product portfolio which covers all the requirements of mobility and transportation, starting from e-mobility, connectivity, autonomous vehicle systems, safety, lightweight and comfort. We have a unique product portfolio which covers adhesives, sealants, conformal coatings, encapsulants, dielectric gels, 3D printed materials, silicone rubbers, moldable optics, self-sealing tires. Our products are designed for the sustainability. So what do you mean by that? Our products are designed in such a way that they will address the current needs of the sustainability with respect to the decarbonization, circularity as well as climate control. Dow constantly optimizes its Scope 1, Scope 2 and Scope 3 emissions while maintaining their product portfolio as well as maintaining the product purchase portfolio while catering to the growing consumer demand. We intend to reduce our Scope 1 and Scope 2 emissions by 50% by 2030 and Scope 3 emissions by almost 25% by 2030, and thus we want to become net zero or carbon neutral by 2050. Here I just want to mention Dow has formed a joint venture with X Energy, which is the leading developer of automatic nuclear reactors, and Dow is about to establish one power grid with an advanced nuclear reactor at one of the sites in North America, and that's how we are committed towards sustainability. Now we will go with one by one with some of the product lines with respect to the difficult applications and which are solve the customer problems, starting with the selective adhesion LSR. Basically, there are two technologies currently which are available when you want to adhere a plastic to the rubber. You have to either go for the mechanical interlocking, or you have to use the primer or a adhesion promoter. When you use the mechanical interlocking, there is no chemical bond happens between the rubber and the plastic. And when you go for the primer application, you have to go for the curing and drying operation. And that creates a problem, because if you have an excess material concentration, then your adhesion gets lost. If you have a lower concentration, then your adhesion gets lost. So we have come up with this specific product which has an inbuilt adhesion promoter. So you will say, what's the difference in that? The product has been tested for the 12 months of shelf life. Adhesion promoter doesn't interfere and doesn't take part in any of the reactions within the systems, and you get the constant adhesion throughout the product life cycle time. We have tested the 90-degree pill adhesion test as per VDI 2019 standards, and constantly get the adhesion on various difficult substrates like PBT, polyamide 6, polyamide 66. We have also tested hydrolysis resistant grade plastics such as PPA, and we found the comparative adhesion layers which is got at the instant adhesion as well as after 24 hours, 1 week, 6 weeks and 12 weeks of exposure. These are some typical applications of selective adhesion in powertrain electrification and autonomous vehicle systems. They can be used for the perimeter and wire seals that require manual assembly that can be converted into the automatic assembly, where precision molding of seals and gasket can be taken place. Typical substrates targeted here are a glass-filled nylon or PBT. They can be used for the connector, battery vent gaskets, and the radiator gasket for the overmolding or 2K molding of the systems. Then LIDAR and the radar basically are the two influential technologies which are used in the ADAS. This selective adhesion technology can be used for the precision injection molding of a perimeter seal for the environmental protection of this housing seal preparation. Then moving towards the new technology that is called low temperature cure. As the name suggests, you can vary the curing profile, you can vary the temperature, you can optimize the product performance, you can go for the fast and deep section cure with the use of this technology. This is the typical example of the technology. You can reduce the temperature, say, from 150 to 90 degrees centigrade. You can reduce the curing time from 1500 seconds to almost 120 seconds by addition of an acceleration additive. And if you just reduce the temperature, say, by 20 degrees centigrade from 120 to just 100 degrees centigrade, you can reduce your scope 2 emissions by almost 15% if you calculate the emission factors based on the Central Electricity Authority database. So that's how it can contribute to the current trends in the sustainability. These are the typical applications which we will going through for this low temperature cure LSR. You can go for the overmolding of a sensitive component such as the PCB board. You can go for the co-molding of low melting plastics, grommets, gaskets, seal. This is the typical seal made out of low temperature celastic silicone with 9402, which is the oil bleeding grade, basically for the cable wire assembly or the connector seal. Then I hand over to Sandesh for covering some of the two topics.
Thank you, Chetan, and good afternoon to everyone one more time. So we're going to talk about something new which is happening in silicon industry. Luxens is probably the first synthetic silicon leather material. And when we talk about in detail, so what are the important trends industry has? We want a product in our car, in our mobilities, which is animal-free, which has a comfort aspect, which is going to help us to reduce the carbon emissions. So our product is exactly meeting all those three important trends for this industry. So it works basically on the four important senses. One is the sense of sustainability, sense of smell, sense of touch, and sense of sight. When we talk about sense of sight, means silicone leather products are easy to clean, they are sustainable, and you get a very good touch and feel, which adds to the comfort of the our automobiles. So our value proposition is clearly based on the environment-friendly material here. It has a lower carbon footprints when we talk about cradle to gate comparison compared to the organic products. And it is designed for eco-conscious consumers, and it is free from animal materials. Important point is you can process lectins with a solvent-free process, which is an added advantage to the overall ecosystem. This product was launched in 2022, and we already have a very good success in China. In fact, our team is working very closely with all the value chain partners, starting from the fabricators to the OEMs. And it has already won global awards for sustainability and also for contributing to ESG standards. Yeah, so moving on to the most important topic nowadays, I mean, typically lightweighting is the most critical trend in the industry, and at the same time, the recyclability as well. So we are coming up with a new product which is called as a self-sealing silicone. This is again possibly the first product globally in this segment, and we already saw a great response from the industry. Now this is a self-sealing. It's nothing but the LSR, which is a two-part material, and it can be dispensed with any of the standard dispensing equipment. You need a very thin layer in the perimeter inside the tire, and even the nail penetrates, the material goes along with that, and when we remove the nail, it will fill up the hole. So the important is there won't be any loss in the tire pressure, and you can have a longevity in terms of, when you try to repair your tire. So ultimately what is happening here is there is no boot extra space required for the extra tire in the car, which is adding to the lightweighting of the overall mobility. So especially for EV sector, we feel that this would be one of the solutions going forward. And again, here we are also closely working with the global tire manufacturers and also OEMs. Yeah, so this is what we talk about. It's a very easy process. You don't need to heat the material. It can cure at the room temperature. If you want to faster the curing process, handling process, the simplest way is to elevate the temperature. And the most important, when it comes to the recyclability of the tire at the end of life of use, you can actually segregate the silicone from the tire material. So it is one of the biggest plus for this. And global companies are collaborating with us, and we are working to make it a commercial success here. The most critical trend today is all about EV, okay? And Dow has a very good products which addresses a very important aspect of safety, fire in the battery packs, and we have a 3 different class of products which are being used by the industry. One is the LSR rubbers, which actually give you additional protection from the flame. We have UL standard products, which will meet those requirements. Importantly, we also saw a great success with the silicone foam, which is being used for the battery pack. It can be complete potting of the module, or it can be a selective potting of the modules. Of late, we also come up with the SCR high consistency rubber. For this application, one of the unique application is bus bar. This can be either calendared, this can be extrusion process, or it can be over-molded as well. So we have the complete series of this product, already got some global approvals in place. It not only gives us the fire safety, but also it gives you a better insulation properties, which are critical for this application. So very exciting range of products here for EV. Of course, this is a limited portfolio which we offer for electrical mobility, but we have a very good thermal management portfolio as well. Yeah, so thank you. Maybe Chetan, you can take it forward.
Thank you, Sandesh. So now we will discuss about the typical requirements of FSR or FLSR, which are meeting the aggressive requirements of automotive and aerospace industry. So we have various compounds and bases which can meet military classification, MIL type 2 class 1, type 2 class 2. We have ATF resistance FEMQ compounds which can withstand the 150 degree centigrade exposure of this ATF fuel, that is Mercron LV or Decron 6, which has been tested for the long-term exposure up to 1500 hours. We have compounds and bases which can withstand the temperature at 225 degrees centigrade while retaining the tensile strength at 165 degrees centigrade. So this unique diverse portfolio can be used in aerospace and automotive industry. What are the typical examples we will cover in the next slide. So this is the typical application examples: fuel line safety seals, oil system seals, turbocharger hoses, membranes, O-rings, gaskets, high resilience, low compression set, fuel contact points. This is the EGR stable compound which has been developed with the fluorosilicon rubber. EGR basically is the exhaust gas recirculation system which is used in the to reduce the NOx emissions. EGR stable compound requires to have acid resistance. We all know the silicon has a very less acid resistance. So we have developed this specialty component which can withstand the acid resistance up to prolonged hours, say 120 hours to 70 hours at 120 degrees centigrade. And this specifications has been tested as per BMW standards, and we found there is no significant change in the desired properties within such kind of high acid resistance environment at the swollen stage as well as the dry out stage. Then this is another typical example of FLSR in a low compression set environment. Basically, as the compression set is low, you get a very good sealing performance. FLSR can achieve excellent compression set without post-cure or even in a post-cure scenario. And this is a typical example which has been obtained with the 40 grade LSR, that is 9201 FLSR, sorry. This is the integrated fuel seal made with the gas diffusion layer of a battery cell, and it has given a constant compression performance at the high temperature as well as under compression. So this way you can use the FLSR or FLSR in a diverse industrial applications which can meet the requirements of the industry with respect to the high humidity, high temperature, high fluid resistance, low compression sets. And that's all from our side. Thank you. And we look forward to hearing from you. Thanks a lot.
Excellent presentation. We have another speaker who will be leaving shortly because he will be catching a flight. May I request?
Yeah.
I'm inviting another speaker, Professor Dr. Kaushik Noskar, to be on the dais to have a presentation on his paper because he will be leaving shortly because he has to catch a flight. And I'll be requesting all of you be seated here as requested by the committee. Professor Dr. Kaushik Noskar received his Bachelor of Technology BTech degree from Polymer Science and Technology in 1998 from University of Calcutta in early 2000. He completed his MTech in Rubber Technology from Indian Institute of Technology, IIT Kharagpur, silver medalist. He pushed his PhD during, he pursued his PhD during 2000 to 2004 from University of Twente, the Netherlands. And since August 2004, he is the professor of IIT Kharagpur Rubber Technology Division. His field of interest are structure property relationship of various polymers and synthetic rubbers, rubber compounding and vulcanization, polymer blends and thermoplastic elastomers, TPE and TPV, rubber nanocomposite, green tire technology, shape memory, polymers, self-healing polymers, thermo-reversible cross-linking, etc. He has more than 180 international journal papers, 90 conference papers, 6 patents, and 15 books or book chapters. He has already supervised 22 PhD students and 40 MTech students. May I request Dr. Professor Kinshuk be on the stage. Regarding previous speakers who spoke largely on silicon rubber, 35 years back when I was a student of Calcutta University, I was studying silicon rubber, our late professor, Professor T.K. Sengupta, he coined this rubber as a magic rubber. And you have seen the magic the rubber has shown in their various applications areas. You know that it is an inorganic polymer. You can have a high temperature resistance as well as a low temperature flexibilities. And also, you can use a functional plasticizers, curatives, and fillers, and you make any kind of product. You have seen the display of various areas, even in the sustainable areas, silicon rubber is being used. I'm thankful for both the presenters for presenting an insightful thing about the silicon rubber applications. Now I'm waiting for Professor Dr. Kinshuk Noshkar to be on the stage.
Thank you. Thank you so much, sir, for your kind words. Thank you so very much. May I request our session chairman, Mr. Chinmoy Ray, to kindly felicitate our two speakers, that is Mr. John Konavis and Mr. Chetan Bhangle. Ladies and gentlemen, let's put our hands together and felicitate our two speakers. Thank you so much, Mr. John Konavis, for your wonderful presentation. And ladies and gentlemen, yes, can we have a huge round of applause, please, everyone? And now may I request our session chairman, Mr. Chinmoy Ray, to kindly felicitate our other two speakers on the stage, that is Mr. Chetan Bhangle and Mr. Sandesh Nadre, please. Ladies and gentlemen, can we have a huge round of applause, please, everyone, for our session speaker. Thank you, sir, for the wonderful session. And it's now time to felicitate our next speaker. Ladies and gentlemen, can we have a huge round of applause, everyone? Thank you. Thank you so much. Thank you so much, speakers. Thank you so very much. Your presentations really means a lot to us. Thank you for sharing your knowledge with all of us. And I request the session chairman to kindly stay on the stage. And thank you so much, speakers, once again. Thank you, gentlemen. Thank you so very much. Thank you, sir, once again. All right, my dear friends, let's move further. And for our next session, may I invite Professor Dr. Kinsuk Naskar on the stage, please. May I request our Professor Dr. Kinsuk Naskar to kindly come up on the stage. And I would request our session chairman to take the proceedings further. Heartfelt welcome, and I believe Mr. Chinmoy Ray has already spoken about our next speaker, so it's not time to let these proceedings go further. Thank you so much.
Okay. Thank you.
So, Professor Noshkar is now in the stage. His subject is that understanding peroxide cohesion, vulcanization of synthetic rubber. Now the stage is yours.
Thank you.
Noshkar.
Thank you very much, Mr. Chinmoy Roy. Can I have my presentation, please? Yeah. Thank you very much for your nice introduction. So, the topic of my discussion today is understanding peroxide cohesion vulcanization of synthetic rubbers. I belong to Rubber Technology Center, and as you can see that, it is in the eastern part of the country. IIT Kharagpur is the first and the largest amongst all IITs, and it is about 140 kilometers away from the beautiful city of Kolkata. Our center, Rubber Technology Center, is a very well-established center. It was established in 1941 under the leadership of Professor S.K. Dey. What you could do, you could see from here that we have several labs, starting from our physical testing lab, processing lab, chemical lab, simulation and modeling lab, thermal lab, as well as rheology lab. I would like to introduce my faculty members. I am now currently heading the center for the last 1.5 years. Along with me, also other colleagues of mine are here, Professor N.K. Singho and Professor Narayan Chandra Das. They also gave talk in the workshop. Also, Professor Shantanu Chattopadhyay is one of the professors who is currently visiting Japan. And we have 3 relatively young assistant professors, Dr. Titash Mondal, Dr. Soumyadip Choudhury, and Dr. Varuni. Regarding my group, the name of my group is Advanced Rubber Composites and TP Lab, what we abbreviate as ARCT Lab. As you can see that different research scholars are doing research on the different fields. However, I would like to mention that some of the thrust area of my research group is high performance TPs and TPVs, where I gave a talk in the workshop in details. Apart from that, we are doing also self-healing rubber, shape memory polymer blends, electron beam induced reactive processing, green tire. I think there are a lot of talks on green tire based on silica silent coupling agents in this conference as well. We are doing quite some work in this particular field. And coming back to what I am going to talk today about the peroxide, so I basically split into 2 parts. First, I'll be talking about the basic concept of vulcanization. Many of you already know. Mechanism of peroxide vulcanization, various structurally different peroxides which are commercially available, their performances and typical applications. However, along with peroxides, also the addition of coagents are important. So I'll be also focusing and explaining the need for coagents along with peroxides. I'll be talking about the mechanism of coagents for the coagent-assisted peroxide vulcanization. I'll show you some of the commercially available coagents in the market and performance and their typical applications as well. Coming to this cross-linking or vulcanization in general, you know that whenever you do talk about vulcanization, basically you are adding cross-linking agents at high temperature and pressure. Your rubber molecules get cross-linked, and you are creating, if you take sulfur, different kinds of linkages like polysulfide linkages or monosulfide linkages or disulfide linkages, depending on the selection of sulfur to accelerator ratio. And many properties are basically controlled by the cross-linking density, which means that the number of cross-links formed per unit volume. But you could see very clearly that not all the properties are either increased or decreased at the same time. So you have to really optimize the level of cross-linking to control and to get the overall balance of all the properties. Well, also you know that you are mixing up raw materials, then fillers, different organic molecules, sulfur, accelerators, etc. There are several stages for rubber vulcanization. First you are mixing, which is followed by forming, then you are storing the materials, eventually you are going for molding to get vulcanization at the high temperature, okay? If you see the kinetics of cross-linking, also depending on the nature of the rubber, you could get different kind of phenomena like reversion, and then you could see that normal cure and marching modulus as well. Something about this cross-linking agents itself. So on an average, we are using about 2 to 4 volume% of the curing additives. However, they determine many of the performance properties like processing behavior, they control the cure kinetics. Just now I mentioned about the cross-linking density. They also largely control the mechanical as well as dynamic mechanical properties, heat stability, specific density, etc. So this 2 to 4% is very important of this cross-linking agent, which determined many of the useful properties of the rubber compounds and play a very important role. Regarding the possibility of various cross-linking agents, mostly sulfur accelerated cure systems and peroxides are most common for different kinds of saturated as well as unsaturated rubbers. You could also think about other techniques like high energy radiations, like electron beam radiation or gamma radiation. Also, you can think about platinum catalyzed hydrosiloxanes for silicone rubber, metal oxide cure for polychloroprene rubber, quinone dioxin for butyl rubber, phenolic or brominated phenolic resin for making TPVs. I also gave a talk on TPV a couple of days before. Also, amine cure is possible for different acrylics. Well, these are all about chemical crosslinks. You could also think about forming physical crosslinks without the need of any cross-linking agent. For instance, if you talk about Craton polymers like broccopolymers, having the combination of hard domain and soft domains, or for example, you can create some hydrogen bonding, or even you can think about ionic crosslinks to talk about this kind of physical crosslinks. Since sulfur is the most important, and I already mentioned that there are possibilities of different types of formation of crosslinks, structures like either polysulfide or di or trisulfide or even monosulfides. And you know that for sulfur cross-linking, the presence of double bonds in the elastomer and rubber is a must. However, when we talk about peroxides, that got the maximum possibility to cross-link both saturated as well as unsaturated rubbers. Regarding the mechanism, well, it works in different stages. So in the first step, there is a decomposition of peroxide, creation of primary radicals under the heat. Then it abstracts kind of this hydrogen atom, and then it forms kind of polymeric radicals. And in the third stage, there is a combination of those polymeric radicals to give the crosslinks. So basically, if I talk about the productive stages, so you talk about the homolytic cleavage, followed by hydrogen abstraction, and then coupling and addition reaction. However, you see that when you heat it up, there, for example, if you take the simple peroxide like dicumal peroxides, you can see that there are formation of different kinds of radicals, and this reactivity of those radicals are very important to understand, which basically eventually control the cross-linking density and things like that. Now, if I compare the bond energy, bond dissociation energy, which is created by sulfur vulcanization and peroxide, you could clearly see that carbon-carbon bonds are formed via the peroxide linkages, which have got highest dissociation energy, bond dissociation energy, whereas for polysulfide linkages, it is the lowest, and monosulfide linkages is having the highest bond energy amongst these sulfur cross-links. So you can already imagine, whenever you talk about high temperature performance, maintaining compression set and all this stuff, you could definitely go for peroxide vulcanization. To give you some ideas about the structure of the peroxides, as you can see that the peroxy group is very important, but the chemical environment around these peroxy linkages play a very important role. And you could see that like ditertiary butyl peroxide or dicumal peroxide or dibenzoyl peroxide is there. The bond strength of different peroxy groups are different depending on the chemical structure. Also, another thing is very important, which is called the half-life time. This means that the time required at a particular temperature to decompose half of its amount. And you could clearly see that different peroxides have different half-life at different temperatures. So this means already that not all the peroxides could act as a perfect examples of cross-linking peroxides. This means there could be some other peroxides which are good for polymerization, having showing kind of good initiator ability, initiator efficiency, but they are not cross-linking peroxides. So what I'm talking about that, so if you just try to plot tau half-life time as a function of temperature, definitely you could see that tau half values are decreased as you go on increasing the temperature. However, the cross-linking peroxides are confined in a particular zone, right? And you need to select that one because in general, if you talk about the vulcanization temperature, that should match with this cross-linking temperature and for peroxides. And that is why you have selected only few peroxides which are basically termed as a cross-linking peroxides. If you try to see the commercially available cross-linking peroxides, and if I take typically, let's say, oxonobel or now it is Norian, you see that typically Trigonox 101 or Parkatox 14 or Parkatox BC or Trigonox 29, Trigonox C, Parkatox PD, they are most important peroxides. And you could see also their safe processing temperature, scorching, scorching, and the minimum cross-linking temperature as well. And you could see that the cross-linking temperature of most of the peroxides are rather high. Well, also you should know that the peroxides can cross-link various types of rubbers. If you talk about dyne rubbers, in principle, it can even cross-link natural rubber or polyisoprene or polybutadiene, but rather it is more common for EPDM and other rubbers, what I'll be talking later on. However, you see that some of the peroxides, it doesn't work for some of the elastomers. For instance, for butyl rubber, it doesn't work. For acrylated rubber, it doesn't work. If you take even polypropylene, it undergoes kind of beta transition. It also will not work. However, also you can try application of peroxides for rubber blends, like for instance, nitrile rubber and EPDM or SBR EPDM-based blends. I did discuss the other day that for peroxides, for TPVs, it is also one of the good choices. As I also showed in the previous slide that you can get in the form of granules or in the form of powder. Another most important thing is that the doses, the concentration of the peroxides, that depends on the level of unsaturation present in the structure of the polymers and also the structure of the peroxides. So here I just tried to show you some of the recommendations for different kinds of rubbers, the doses in terms of 100 part of pH, 100 part of polymer. So you see also for different peroxides, and if you select different rubbers, the dose levels are basically different. Regarding the cross-linking peroxide product form and compounding, I just mentioned that you get in the form of 40% powder or 40% granules or even 40% polymer bound. And if you have to process that, you see that I tried to highlight the standard technology in green color and red color, which is not okay, and others are applied but not common, which is highlighted in this orange color. Okay. So if I just try to compare sulfur accelerator system for a particular rubber and compare the properties with peroxides, you see that there are many things which are advantageous and some things are not good. So for instance, if you talk about reversion, if you use peroxide, there is hardly any reversion. Okay, so it is very good. Tensile strength might drop by about 15%, or tear strength also might drop by 30%. But as soon as you talk about high temperature properties and heat resistance and compression set properties, especially at high temperature, peroxides win over sulfur accelerator systems. I think whatever I talked about that, also it is highlighted over there. My intention is to show that, okay, you have to see both the sides of the coin, right? So some of the properties of sulfur is definitely better, and some of the properties of peroxides are better. Well, now about this pattern of decomposition. Well, some people sometimes complain that, yeah, peroxides are smelly stuff. Why should I use that, right? So you have to understand the chemistry, why it is smelly. So if you typically talk about Percodox BC, and if you follow the decomposition pattern, you could see that there is substantial amount of acetophenone, which is generated after decomposition, and that is the culprit for creating smell, which perhaps you don't like. However, if you change the peroxide structures and switch over from Percodox BC to Percodox 14, you see that there is hardly any possibility for the formation of acetophenone, which also explains why it is not smelly at all, right? So these are the few things you have to keep it in mind. Apart from these, sometimes you see that the scorch safety for some of the peroxides are not that good. There is also solution for that. You can use some kind of scorch retarder. One example I showed over here, that is BHT, like butylated hydroxytoluene, which is also commercially available. And you could see that after the addition of 1 to 4 millimoles and 10 millimoles of peroxide, there is increment of about 25% of the scorch safety. And over here, you could clearly see if you make kind of formulation based on EPDM rubber. I think this is typical formulation, EPDM, zinc oxide, stearic acid. And on the left-hand side, you see that sulfur accelerator system is there. We compared the properties on the right side, that is with peroxides. And as I said already, you could see the real values of compression set at various temperatures. Let's say when you do the experimentations for 70 hours at 70, 100, and 120, you could see that the peroxides exhibit much better compression set properties over sulfur vulcanization. Okay? Now I would like to give you some statistics and market trends. You see that in 1970s, if you talk about, for example, radiator hose, the tube, the cover, and tube plus cover all were basically cross-linked or vulcanized by sulfur. The trends are changing. 1980s, 1990, already you see that it is done mostly by peroxides these days, and beyond 2000 it is even more, right? Here it is even more specific, like 1991, if you take the statistics, all the products based on radiator hoses were basically cross-linked by 85% by sulfur and 15% by peroxide. 1997 onwards, the trend has been completely reversed. Okay? Well, also for some specific high performance rubbers like hydrogenated nitrile rubber, of course, hydrogenation improves the heat stability by 25 degrees centigrade. For that kind of polymers, like I talked also about EPDM, it is possible by both sulfur and peroxides. So you could see that peroxide cross-linking systems are also increasingly getting popular. And I just tried to show you, if you talk about the residual double bonds present in this HNBr, if you go from 1% to 10%, you see that several properties, if you cross-link by peroxides, are basically improved, like cross-linking density, compression set, modulus, hardness, etc. So in principle, now if I try to be more specific about the peroxide cross-linking and the selection of polymers and rubbers, you see that in principle, for dyeing rubbers also it is possible to apply peroxides. But if you talk about the tire rubbers, we don't use, so it is hardly used or limited. But in principle, it is possible. If you take polychloroprene rubber or chlorosulfonated rubber or polysulfide rubber, it works, but also it finds limited use. So mostly peroxide cross-linking I recommend for these rubbers, like hydrogenated nitrile rubber, for EVA, for silicone rubber, to make cross-linked polyethylene from polyethylene for cable applications, fluorocarbon elastomers and EPDM. I think that these are very commonly used, and you could see already some of the portfolio of the products. More specific examples, well, you see that for cooling hose, coolant hose, brake hose, radiator seal, other kinds of profile and seals, steam hose, O-rings, oil-resistant cables, you see the selection of the elastomers and the motivation behind the for the use of this rubber as well as peroxides, it is also highlighted. So in principle, it finds application in automotive industries, in building and industrial applications, as well as for offshore and automotive I already did mention. Well, we have to now see the other side of the coin, right? So what are the challenges with peroxides? I think it is sensitive towards oxygen during curing. That creates sometimes kind of surface tackiness, which is not good sometimes. And this is a serious drawback. It also interferes with some of the other compound ingredients like antioxidants or process oils, or if you select any acidic fillers like, for instance, silica, colorants, etc. And as I mentioned already, there is a 15% drop in the mechanical performance properties. And also I mentioned that for some of the rubbers, it doesn't work. Okay? So therefore, the motivation for coagents come into picture. So we should know that how coagents work now. So you see that as I already described the mechanism of cross-linking agent, but in presence of coagents, there is the formation of bridge-like structures because coagents have very reactive groups. So in presence of peroxides, they form kind of multifunctional cross-linking sites. Therefore, there are several advantages, improvement of other properties. I'll just show after this slide. And you can see now the various commercially available coagents are in the market. So type 1 and type 2 you can classify. In type 1, you can talk about, let's say, trimethylol propane triacrylate, HBA2, zinc diacrylate or zinc dimethacrylate from Sartomart. And in type 2, you have most common ones like TAC, triallyl cyanurate, or triallyl isocyanurate, or even vinyl containing, 70% vinyl containing styrene butadiene copolymer that are this is commercialized. I just mentioned that what are the advantages? Well, since the cross-linking density is much higher, you form kind of more tighter network. So there are several advantages of the cross-link network. So improvement of the heat edging, improvement of the modulus, higher tensile and tear strength, higher hardness, better compression set, as well as better abrasion resistance. Okay, I just tried to highlight and compare some of the properties of the various coagents. Clearly, you could see if you compare A in the left-hand side where it is only peroxide, and if you see B or C, in presence of coagents, you could clearly see there is a kind of improvement of the delta torque, right? So there is an improvement of the cross-linking density. And you could see the performance behavior of different kinds of coagents, and kinetics and cure state has been changed. Also in terms of scorch, safety, and other properties, you see that various coagents are performing differently. So you have to select the correct coagent in combination with correct peroxide. Okay? And also there are sometimes improvement of the adhesion strength, like especially if you talk about zinc-based diacrylate as a kind of coagents, there are tremendous improvement. Last thing I would like to talk about, and what I am doing now, is why not? We can go one step further. I have been thinking about exploring hybrid system, and one of my PhD students is doing work on this. So it means that we now know advantages and disadvantages of sulfur and peroxide system. why don't we think about combining these two together and what I call hybrid cure system. Just I would like to give one idea. It is one of our published article. So we kind of done this Taguchi methodology for the optimization for the dose of peroxide to that of the sulfur. As you can see that, for instance, you can use 0.5 part of sulfur and 0.5 part of kind of systems. And then you see that this combination, so 0.52, 0.53, 0.54. So we optimized after taking this optimized dose for EPDM rubber, Kelton, and we got very good promising results. So in summary, I just would like to mention that cross-linking or vulcanization of synthetic rubbers by peroxides are getting increasingly popular. And there are several advantages of peroxides over conventional sulfur accelerator system. Depending on the nature of rubber, you need to select the correct peroxide along with correct coagents and their relative doses. The pHR is very important. Handling and disposal of peroxide are a bit tricky. And further improvements in performance properties can be achieved if you add coagents along with peroxides. This is my group picture, and thank you very much for your attention. Thank you so much.
Excuse me. Yeah. Excellent presentation by Professor
Thank you.
Nashkar. Any question from audience? If not, I just want to say, Professor Nashkar, whenever we are attending any session of yours in any conferences, you are taking us down to the college days when you have been understanding the basics, and you have taken from the basics to the hybrid model, wherein we can use both the COR system in one place. What a wonderful presentation.
Thank you.
Thank you.
Thank you so much.
Thank you so much, Professor Dr. Kinsuk Naskar, for the wonderful presentation. Ladies and gentlemen, can we have a huge round of applause for him, please, everyone? And may I request our session chairman, Mr. Chinmoy Ray, to felicitate our Professor Dr. Kinsuk Naskar for the wonderful presentation. Ladies and gentlemen, can we put our hands together for Professor Dr. Kinsuk Naskar once again? Thank you, sir. Thank you so very much. And it's now time to felicitate our session chairman, Mr. Chinmoy Ray, and to do the honors, may I request Mr. Prasant Wani, Director and CEO of Pooja Fluid Steels Private Limited and Managing Committee member of All India Rubber Industries Association, to kindly come up on the stage and do the honors. Welcome, sir. And may I request Mr. Prasant Wani to felicitate our session chairman, Mr. Chinmoy Roy. Thank you so much, Mr. Chinmoy Ray, for conducting the session wonderfully well. Thank you so very, very much. Thank you. Thank you, gentlemen. All right, ladies and gentlemen, it's now time to break for lunch. We shall be taking exact 1 hour lunch break. I would request all of you to kindly assemble here exactly after an hour. And yes, we would be resuming our final session of the day of IRE Mumbai 2024 post-lunch. Thank you so much. Goodbye. Bon appetit.
Thank you.
एक आपके वाला माइक होगा. I don't think I need this. Okay. I feel like we're too few for me to stand here.
Okay, the mic is on. Just go on.
Testing, testing. Perfect. Right? Yeah. Okay.
Yes, yes.
Ma'am, do you want a laser or something?
Testing, testing. Looks good. Thank you. Very bright lights. Rakh lo. Thank you. Good afternoon, ladies and gentlemen. I know you're at the end of a very, very busy 3 days at the India Rubber Expo. It seems to have been extremely successful. Thank you so much for waiting for the final presentation, which is mine. I'm honored to have you here and listen to me. The group is seemingly small, but it's not the size of the group that matters. It's the interest in the small group that matters more. So since we are so few people, I am considering coming down there so that you can see me more clearly. And if you have any questions to ask me, or if you want to make this more interactive, you can just speak to me, you know? Yeah? So I'll come down. Perfect. So much better. Yes. I suddenly feel like I can see you so much better. Okay. Can we have the slides on? While they're putting the slides on, I want to start by telling you that I am here because of two very important people who are very well known for their integrity in the industry. One, of course, is Mr. Pankaj Bhatnagar, who's sitting here, and Mr. Vikram Makar, who's also been instrumental in organizing this event. It's because these two people thought that what I have to say is valuable for you to hear that I'm here. I'm honored by that trust, and I take that responsibility seriously. I take your attention and your time seriously. So I'm going to keep this as short as possible, as informative as possible, and dive right in. Slides?
Mostly the editor will announce and check and then we'll start the presentation.
So why did you, oh, okay. So what do you want me to do now?
Yeah, so basically, editor will
Can you, oh, is my mic on? Okay, I've just been told that there's going to be an anchor and a chairperson joining us shortly, after which I can start. So while my introductions are done, we'll wait 5 more minutes, and yeah, I'll see you very soon.
Hey, ladies and gentlemen, welcome back to IRC. Well, I'm sure with our taste buds satisfied now, we have arrived in the tasteful final session in India Rubber Conference, where we shall be meeting our final speaker. May I request Ms. Bani Benz to kindly come up on the stage. Ladies and gentlemen, let's hear a huge round of applause for Ms. Bani Benz. Indeed, my dear friends, this would be the final session of IRE Mumbai 2024. Hi, welcome back.
Hi, thank you.
Also, to conduct this session, I would like to invite the session chairperson. In a span of 22 years, he has a vast experience in rubber compound development, cost reduction, rubber product development, failure investigation test methods development, polymer nanocomposites involved in indigenization of projects for defense and nuclear sectors. He has more than 30 publications in national and international journals in his name. He has been chairman BIS PCD 29, member BIS PCD 13, ISO TC 45, BIS TED 7, BIS ME 17, BIS PCD 28, etc. He has been awarded with many accolades like IRMRA, Meritorious Cash Award for Successful Development of Polymer Gauntlets, NAIP Award 2012 for successful execution of rubber dam project sponsored by World Bank from ICAR, Ministry of Agriculture, Government of India, from the hands of Governor of Goa and Minister of MP. Bharat Seva Ratna Gold Medal in the year 2016 from GEPRA 6, ISO TC 45, Long Service Award 2019 for contribution to international standardization, and many more. Well, he is presently working as Director, IRMRA, Ministry of Commerce and Industry, Government of India. Ladies and gentlemen, let's put our hands together and welcome Dr. Rajkumar Kasilingam, everyone. A very warm welcome, sir, and I would request you to kindly conduct the session, and let's introduce the speaker out here.
Good afternoon, everybody. First of all, I would like to thank the organizer for giving this opportunity to chair a session, and I think there was a little confusion. Probably the session has been pushed a little bit due to the arrival of our Honorable CIM, and of course, we had a wonderful session with him and a lot of commitments and a lot of expectation from the rubber industry. We all heard about news from our Honorable Minister, and so there was confusion basically. So thank you very much for being with us. And so the session is open for, and I would like to call upon Ms. Bani Benz. She's a communications manager from Global Platform for Sustainable Rubber. And I think she was already introduced. She was almost starting her session, but of course it's my duty and privilege to be introducing her. And she's a communications manager of GPSNR. And where her work focuses on member engagement and public outreach about the organization's mission. She is based in Mumbai and, of course, has a strong interest in bringing sustainability into the fold of the natural rubber supply chain. I think it will be wonderful to hear from her, and I welcome her to start the session.
Thank you. I'm going to come down now, as promised, so we can do this in a small group with questions, yeah? Sir has already introduced me very kindly. I've met some of you earlier, so I'll not go over who I am, what I do. I will start with my organization. It's called the Global Platform for Sustainable Natural Rubber, or GPSNR, which is a very, very complicated acronym for a very simple organization. What does it do? It's a platform for natural rubber sustainability standards. We already have over 300 members globally and represent 60% of the world's natural rubber demand. How does that work, and how is that interesting or important to your work in India? No matter where you sit in the supply chain, I'm going to skip these slides, but just give you a sense of these people who are currently part of the value chain and are deciding what sustainability standards should be set globally for your industry. I'm sure you see some names here that are already either your customers, your suppliers, your buyers, your dealers. Soon they will be asking you for GPSNR standard compliance, and that's why I am here to talk to you. Again, I'm going to skip this, how we work technically in terms of our executive committee, our working groups. Let's get down to what do all of these people do? They come together on one platform and do what, right? I think that's a very fair question. Step one, as soon as they come into a fold, become GPSNR members, they start first with a commitment and then on reporting. They commit by changing their natural rubber procurement policies and adding and integrating sustainability into those procurement policies, which our team helps them to do within the Secretariat, which is a very objective, small, lean team, no leanings to any specific part of the supply chain. And then you start reporting on another standardized set of questions on sustainability, on the commitments you've already made in the policy framework. You do this in the first year, and this reporting is completely anonymous, not anonymous, sorry. We know it's you, but it's not published. It's not public. It comes to us, and we work with that in establishing a baseline for you and your specific company on sustainability. What's in the policy framework? What is your policy going to look like once you integrate it with sustainability? Just a set of social, economic, environmental commitments that you have probably seen in big certifications: zero deforestation, respect for customary and land rights, indigenous rights. I can send across the types of policy commitments to anyone who's interested. Please meet me after this. What's in the reporting requirements? Exactly the same thing in the policy framework, but translated into questions on what you're doing about it. This is a self-assessment. Nobody is monitoring. Nobody is checking whether it's right or wrong. You are telling us that this is your reality on the ground. Step 2 is making progress on implementing those commitments. How do you do that? You do that by setting or working towards some minimum requirements that together as a supply chain you will decide when you come together on this platform. Some of these requirements have already been decided by 60% of the supply chain. These are in some broad themes that include due diligence, supply chain mapping, risk assessment, and shared investment. Now, we will support you on some common tools and operational guidelines for these requirements in year 1 and year 2. And finally, in year 3 or in year 3 and 4, based on how your progress goes, a third-party assessor will come to your operations to check if you are meeting those minimum requirements. Finally, you will be able to claim either to your buyer or to your consumer that whatever product you have been making is sustainably sourced natural rubber and can be fit for any regulation, any legislation on sustainability that either the EU or any other country throws at you, yeah? Now, what is in it for you, I think, is a very fair question to ask again. What is in it for anyone in India? One, it's a very credible way to make claims. It is the industry standard on claims on sustainability. If you supply to anyone on the previous slide, they will require these requirements of you anyway, so you may as well have them firsthand. If you don't require these things to sell to your consumer, if your country legislations don't require it, like India, for instance, doesn't require it right now, we all know that it will very soon. So if you ride the wave of change faster than you're expected to, you're already in a good place and you've invested in the right mechanisms before somebody gets on your head to invest there. You collaborate with global peers to tackle very systemic challenges. As far as traceability is concerned, as far as supply chain mapping is concerned, one company cannot do it. We need global operational systems and standards that will help us do it. You can also train your company's sustainability representatives, and as a body, you can influence policy and legislation. We are the supply chains representatives to the EU in many ways on the EUDR regulation. We are currently in the process of putting together a letter to the EU and presenting it to them in Brussels about smallholder inclusion and livelihoods and customary rights, especially in Southeast Asia, because they are going to be the ones most impacted by EUDR legislation. Value for Indian players, of course, is support on complying with international policy and legislation when you require it, access to international guidelines, operational and implementation tools, and the ability to make very globally accredited sustainability claims. That's really all from me for this small audience, but I'm very happy for us to make this a small group and ask questions or answer questions. Any questions? Any? Sir?
Hello. I have very basic questions. Is
Please.
GPSNR is Indian company?
No, sir. We're a Singapore-based global platform.
Okay.
But we're registered in Singapore as an entity.
Okay. Okay. And you have office in Mumbai, you said?
I am the office in Mumbai.
You are the office in the Mumbai?
Yes.
Okay, I understand that. Okay. So, okay, so the certification, you are facilitating the certification for GPSNR?
Certification is a very difficult thing in natural rubber, sir, as you must already know, because the land is so fragmented,
okay.
The land on which smallholders grow it, that it's impossible to certify, which is why risk-based assurance is possible, where we are trying to understand what the risks are in each area through our member companies, and therefore assessing those risks, and then based on that assessment, helping our members claim if their product is sustainable or not.
Okay. Last question, what is the membership fees?
It varies based on the profit each company makes, whatever their net revenue is. I'm happy to share that offline. Okay. We are a no-profit, no-loss organization ourselves. all our membership fees goes in either capacity building or in running the direct expenses and operations of our secretariat. But we don't make any profit of this, yeah?
That's good, that's good. Because why I'm telling is that IRMRI, where I am belong to, is also not for making profit organization under Government of India, is facilitating similar certifications and all the things basically, and help each other to
Absolutely,
in the
absolutely.
sustainability chain. So we are working on that basically. So wherever possible, we can have a collaboration and work on
Absolutely.
that.
I'll connect with you on
Yes.
Monday morning.
Yes, no problem.
Thank
That's
you.
all from me, and I think the floor is open for any questions from the audience actually.
Hello, myself Ram Prasad Das here from Harrison's Mintech. I look
Nice
after
to
the
meet you,
western
sir.
region from the rubber industry.
Nice to meet you, sir.
Yeah, my pleasure. Since you are involved in the natural rubber industry, on the supply chain, sustainability, all those sides, what we felt is the need, the Indian natural rubber plantation sectors, we need the infrastructure development, which is happening much more in Bangkok or Malaysia or Thailand. If you look at the plantation sector in Kerala or in Tripura or in Assam, they need the infrastructure development, which is a mechanized sectors, which is very much happening in Bangkok and other natural rubber producing countries. So your company being a NGO, so since you're already involved in the natural rubber, probably I think you can collaborate with the Government of India or Ministry of Commerce, involved in the alliance with the development of the farmers who are actually involved in the ground level from the plantations, which is the need of the hour.
Please tell us how we can connect with the Government of India, and we will...
We had few years ago, Mr. Piyush.
Yes, of course.
Yeah, I think you were there.
Yeah.
But we need a roadmap. We need very much an infrastructure development strategy. Like your company is very much involved in the natural rubber side. So probably sustainability, supply chain, you can value add more on the infrastructure development side.
I fully understand what you're saying, sir. In fact, for us as well, we are realizing slowly that working with governments is our next step. So we have started to work with the Thailand government, and in very, very small measures for capacity building itself for smallholders. But that's a great idea. We'll take it up with the Indian government as well.
Thank you.
Any other questions?
Okay. If not, I thank you for your time and wish you a wonderful
Please
weekend.
give a round of applause for.
Thank you so much for your time. I'm very appreciative.
Thank you, thank you.
Thank
Mr.
you,
Banas,
sir.
for-
Sir,
Thank you. Thank you so much, Ms. Bani, for the wonderful presentation. Thank you. And may I request both of you to kindly come up on the stage, please. Also, I would be requesting Dr. Rajkumar Kasilingam to felicitate Ms. Bani. Ladies and gentlemen, can we have a huge round of applause for Ms. Bani for the impeccable presentation? Everyone, can we hear it out for Ms. Bani? Thank you. Thank you so much once again, Ms. Bani. And moving further, I would request Mr. Ram Prasad Das from Harrison's Mintech Private Limited to kindly come up on the stage and felicitate our session chairman, Dr. Rajkumar Kasilingam. Welcome, sir. Well, ladies and gentlemen, can we have a huge round of applause for our session chairman, Dr. Rajkumar Kasilingam. Thank you so much, sir, for doing the honors. Thank you so very much. Thank you so much. And indeed, ladies and gentlemen, this was the last session of IRC. And at this moment, we shall be declaring IRE Expo, IRE Mumbai 2024. Yes, we have to conclude here. Thank you so much once again to all our sponsors, to all our exhibitors, to the lovely audiences, to all our speakers, our session chairmen, and to everyone who has made IRE Mumbai 2024 such a grand success. Thank you so much. And with this, I, Lekha Raj, would now sign off. Thank you so much. Goodbye. Take care.